section 8.5, using the distributive property, in Algebra 1, page 520. Okay, section 8.5. We're going to talk about this word today. Kind of an interesting word. It's called factoring. You're going to hear that a lot. Factoring. It looks like this. F-A-C-T-O-R-I-N-G, factoring. It's writing a quantity as a product of prime factors. So since you're writing it as prime factor, it's called factoring. An example would be like the number 6. We would say 6 is the product of 2 times 3. And 2 and 3 are both prime factors. Now we cannot say 1 and 6. So if I say 6 equals 2 times 3, this is called factoring. I cannot say that 6 equals 1 times 6 because 6 and 1, neither one of them are prime. What does it mean to be prime? What does it mean to be prime? Okay, prime is when your factors that you have are numbers that, or expressions that have 2 factors, 1 in itself. So 2 is prime and 3 is prime. What's the next prime number after 2 and 3? 5. 5 is prime. 4 has factors of 2. Okay? So that's what prime means. Now, it'd be great if that's what we just focused on numbers, but we actually have algebraic expressions that we're going to factor. Okay? So, all right, Jackson, you with me? All right. So, the first part of factoring today is using the distributive property. So let's talk about the distributive property. The distributive property, actually we've only used it really one way, and we've said A times the quantity B plus C equals AB plus AC, right? We've distributed the A in. But the distributive property also has another part to it, and it says and. We don't use that very often, but and AB plus AC equals A times B plus C. Now some people say, well, that's the reverse of the distributive property. These both have A, so I can rewrite it as A times B plus C. They have a common factor, you see. They have a common factor, so they're not prime. So writing it as a prime factor, I have to factor that A out. And most people don't understand that this is also the distributive property. It can either go in or it can come out. You understand that? Okay, let me give you an example. If the directions would say, use the distributive property to factor each polynomial. Okay? So we're going to use the distributive property, only we're going to use it weirdly. You're not going to be used to this. We're going to use it kind of what you would call in reverse. So number 1, we would have 27 y to the second plus 18y. Our goal is to look at, how many terms are there, Ryan? How many terms are in that polynomial? 2. And is there anything that they have in common? The 2 terms, this term and this term. Let's talk about numbers. What do they have in common? Tyra says 3. Is there anything bigger than 3? 9. All right, so they both have a 9. What do they both have in terms of y? 1y. They both have 1y. Now one of them has 2, but both of them have 1y. So I'm going to take that out now of the quantity, and I'm going to put in the quantity what is left when I take this out. When I say I take that out, I mean I divide by it. So 27 divided by 9 is what, Chuck? 3. That's what's left there. And y squared divided by y is what? If you have 2 y's and you take 1 away, how many do you have left? 1. So 3y plus 2. Where did she get 2? 18 divided by 2, 18 divided by 9 is 2, and y divided by y is 1, right? So we get 2. There's no y's left. This is called, using the distributive property, factor. These are both prime factors. Do you understand that? Now, I say it's factoring using the GCF. I'm going to put that in parentheses. Why would I say factoring using the GCF? First of all, what is GCF? Greatest common factor. And what is the greatest common factor of this and this? What? 9y. The greatest common factor, Caden, of these two is 9y. And I factored that out. Do you understand that? So this is called factoring. All right? Let's take a look at this one. Number 2. A negative 4a squared b minus 8ab squared plus 2ab. Okay, how many terms do I have? 3. So how many terms am I going to have in my parentheses? 3. Okay, so what do they all have in common? What's that? They have a 2 in common, right? That's it, right? I mean, I know there's a 4 and an 8 there, but how many A's do they have in common? 1A. How many B's do they have in common? 1B. All right, I said there's going to be 3 left over, right? So if I take 2 out of B out of the first one, what do I get?
2A.
Oh, I think it's a negative 2, isn't it? Negative 2A. What about B? Nope. All right. Now, what about the second one? Is it positive or negative?
Negative.
It's negative. All right. I can do subtract, or I can do plus a negative.
Negative 4B.
Negative 4b. Does everybody see that? But I said there were 3 terms. What's the last one?
0.
Not 0. 1. Any number divided by itself is 1, not 0, Jackson. The common error is that people put 0 there. Allie, do you have any questions about that?
No.
Are you sure? Okay, so here's one I want you to do by yourself. 7x squared y squared plus 21 xy squared minus xy. Okay? Would you do that, please? What's the greatest common factor, Charlie? 1? Yep. How about any x's? 1x. Any y's, Charlie? Don't they all have a y, Charlie? Yeah, since they all have a y, we got at least 1, right? And I think that's all we have, correct? Okay, so we have 3 terms, we have 3 left. All right, if we pull out the 1xy, Tater, what do we have the first term? What's left? Divide this by this. What do you get? Divide this by this. 7 divided by 1 is 7. X squared divided by x, Tater. Y squared, yeah, okay, xy, you said it. All right. Plus, because this is a plus. Jackson? 21. Y? Is that it? All right. Plus? -1. Got it? Ashley? Questions, Chuck? TJ? We good? All right. Okay, now I'm going to draw a line because what we're going to do next is about 4 terms. Okay, and I'm going to begin a little weirdly. Okay, and I've never began like this, but I'm going to try it. Let's say that I had x times 2 plus ab minus y times 2 plus ab. All right? Now my question to you is, how many terms are there? Be careful. Brian. No. There's 2. Would anybody like to tell me what they are? Okay, then stay with me. Here's your first term. Here's your second term. Now, you tell me, what do both of those have in common if they have anything in common?
2 plus AB.
The whole quantity 2 plus AB. Don't they both have all of that in common? Jackson, do you understand that? Now, Jackson, do you understand that? Okay, Jackson, what's left, Jackson? Looking at this term, if I divide by this, what's left? X. X is left here, and then this subtraction, and what's left here? Y. Look at that. That is a product of prime factor. Do you understand that? All right, so going into that, all right, take a look at this one, number 4. And this is where we do 4 terms. So off the right here, I'm going to start by saying 4 terms. You can recognize these because they have 4 terms. All right, let's do this one. 4QR plus 8R plus 3Q plus 6. All right, any questions about that? How many terms does it have? 4 terms. Okay. Now, when you have a 4-term polynomial, first of all, it's possible to move things around to get the things that you want together. But what you want to do is you want to group things so when you factor it, they have something in common like these 2. Okay? Now, I'm just going to take a guess, and I'm going to group the first 2 together and the last 2. But before you do any of that, change all subtraction to addition. Before you do any of this, change all subtraction to addition. And that way, if you have to move things around, right, then you can. Because we don't have a commutative property of subtraction. We only have a commutative property of addition. All right, so I'm going to do this and this. Now, I chose the first 2 and last 2. I don't know if this is the way to do this. Okay? Now, instead of going to the right, I'm going to go down. All right? What do these 2 have in common? Just these 2. I think they have 4 in common, don't they? 4, what else? R. Do they have a Q in common? No. So what's left here? Plus 2. All right, so now when we factor this one, we want to have a Q plus 2 somewhere. Okay? So what do these 2 have in common? A 3. So we're going to take a 3 out. What is that? Q plus 2. Do we have a Q plus 2 in common? Yes. This is a term and this is a term. We're right where we were here, only different letters, right? So, guys, I'm going to factor out from this term a q plus 2. And I'm going to factor out, and what's left here? I'm pulling a q plus 2 from both of them. What's left here? 4r plus 3. That's my final answer. Okay, questions about that? All right, let's try. I'm going to try several of these, Jackson, so hang with me, because these are the hardest part of them, okay? So I'm on question number 5. And I got this one, 2u squared. I'm nervous about using u and b, but I'm going to do it. Minus 15 minus 6u squared plus 5b. Okay? Does this one have 5 terms? Or excuse me, does this one have 4 terms?
Yes.
What did I tell you to do the first thing?
Change
Change
all subtraction to addition.
subtraction to addition. You ready? Here we go. Plus a negative 15, plus a negative. Now, if I look at these two, do they have anything in common? No. These don't either. So what should I put together? Could I put this one and this one together? And this one and this one? All right, so let's do that. 2u squared. What property am I using? I'm using the commutative property. Did you notice that I put the 5v first before the negative 15? Did anybody notice that? It's easier to factor when you put the variable first. I'm just telling you. Okay? All right, let's take a look at these two. All right, let's group them. Now, I don't know if this is the right way to group them. I'm just taking a guess. You might have to erase and start over. I don't know. It's a guessing game. So what do these two have in common?
2.
2. What else?
U squared.
U squared. So what's left here?
Negative 3.
What's left here? B plus.
Negative 3.
All right. What do these two have in common? Okay. What's left? Do I have the same thing? Do I have something in common? Right? What is it?
B plus a negative.
That's right. So now I'm going to take that out, and what's left in the first one?
2 squared.
And what's left in the second one, Allie? This one. If I pull this out, what's left? I pulled out the b plus a negative 3 from both of them.
So
5. Do you see why I underline them? Is it easier to factor when I underline them? Okay. All right. Chuck, you have a question.
Okay, so like when you get to the basis and the negatives, and when you get to negative 3, is that just like,
Okay, that's a great question. I look at these two, correct? And I say that they have 2u squared in common, right?
yeah,
If I take 2u squared from this, that leaves v, right?
yeah,
But when I take 2u squared from this, I have to divide, right? I take a negative 6 divided by 2, which is a negative 3. And u squared divided by u squared is 1. I'm really dividing it out. Does that make sense? So I would divide this one, I take 5v divided by 5, which is v, and the negative 15 divided by 5, which is a negative 3. Does that make sense?
yeah.
Okay. All right. Jackson, any questions? All right. Now it gets interesting, if it already hasn't. 2mk, that's an m, minus 12m plus 42 plus, or excuse me, minus 7k. Okay. All right, let's change all subtraction to addition, correct? Boom, boom. Questions? You all understand that? Okay, do these have something in common?
Yes.
Do these two have something in common?
Yes.
All right, so let's just take the first two and just see if it works. So I'm going to just group these two, and I'm going to group these two. I don't know if it's going to work, but let's try it. What do these two have in common?
Two.
2. Anything else? Yeah. Okay. Now, Charlie, what do I have left in the parentheses? K plus negative 6. All right? All right? What should I take out of this one? Tyra? You can take a negative 7 out? Okay, let's try it. What's 40? Let's just take 7 out. Okay? Should we just take 7 out? Alright, so what's 42 divided by 7? Plus, what's a negative 7k divided by 7? Negative k. Now, are these two the same? Look carefully. No, they're not. What's wrong with them?
The K is positive on one
Yeah.
side and the K is negative on the other.
This k is positive, this k is negative, this 6 is negative, and this 6 is positive. So it's like they're opposites of each other. In fact, they are opposites of each other. So you want to hear the funny story? I knew this was going to happen. I've never had anybody say take a negative out, but Tyra did it. I wanted to show this. But Tyra took the negative out, and it almost missed showing it. So I forced her to take just the 7 out. But Tyra's right. If we take a negative 7 out, okay, so I'm going to take a negative 1 out. So I'm going to rewrite it. K plus a negative 6. I'm rewriting it so Braxton will have it. But I'm now going to take a negative 1 out of this. So that makes this a negative 7, which is what Tyra wanted. If I take a negative 1 out of 6, that means I take 6 divided by a negative 1, and it becomes what? Negative 6. If I take a negative k and I divide by a negative 1, I get what? Now are they the same? Yes, they are. I know they're flipped, but they have the same quantity. So I can use this as both of them, right? And I can factor out a k plus negative 6. Now, do you write k plus negative 6 or negative 6 plus k? It doesn't matter. What's left in the first one, Jackson?
2.
What's left in the second one, Caden? All right. And do you see how that works? Questions? Tirsa? You have any questions? Nope? Okay. I was going to look here real quick. We're going to do 16 through 46 even. There was one that I wanted to look at. Let's do 44, just as a quick one. 44.
What page is it?
It is page 524. 16 through 46 even. I'm going to change that. Can we just go to 44? We'll do the last one together. 2a to the third b minus 8a squared plus 12b minus 3ab squared. Did I copy that right? Make sure I copied it right. Okay. All right. I'm going to change this to plus and negative, and this plus and negative. Do the first two have something in common? Do the last two have something in common? All right, let's try it. Once again, it may not work, guys. Okay? So what do the first two have in common? 2. What else? A squared. A squared. So what do I have left out of the first one? A plus a negative. What do I have out of the second one? Negative 4, right? On the first one? Yeah, you have AB. You're right. Thank you. Who said that? Ryan, good job. All right, what about this one? 3? Okay. And 3B, isn't it? 3B? What's left out of the first one? What's left out of the first one? Would you get that, please? 4 what? Just 4?
Negative.
What's left out of the second one? What is it? Thank you. Just set it right there. I'll take care of it. Thank you.
One of those needs to be a negative.
What is it?
One of them needs to be a negative.
Okay, but what do I have when I take the 3b out? Negative AB, right? And he's right. They're the opposite of each other, right? So what should I have taken out of the second one? I'm going to take a negative out now. So I'm going to go back through and I'm going to take a negative out. So I have a negative 3b. That makes the 4 what? Negative? And the AB positive. And that's exactly what I have here. And so I like AB plus a negative 4, so I'm going to go ahead and take it out. And what is left?
2a squared and negative 3b.
2a squared plus negative 3b. Okay? Now you guys understand that if I FOIL this, I would get this. I'm reversing FOIL. If I FOIL this, I would get this. Do you realize that? Well, realize it because that's a coming. Okay? So you have your assignment. It is due